This is the second part of 5.5 for U sub. So let's look at a problem like number 24. It says the integration of x square root of x plus 2 dx. So we're going to let u equal x plus 2 because it's the inside of the composite function. And then du equals dx. So the integration of x square root of u du. Now the problem here is this x. There's no way to get rid of it. So you have to use a different technique. Let's go back up here and let's solve this for x. So we know that u equals x plus 2. So in order to solve for x, let's subtract 2 from both sides. So u minus 2 equals x. Now we can put that in down here and say the integration of parentheses u minus 2. And then the square root of u we're going to write as u to the 1/2 du. Now this is important because here we have a binomial being multiplied by a monomial, but there's no power on the binomial, so we can distribute this monomial through the binomial. So that's helpful in a big way. It doesn't work up here because you can't multiply this x into a square root. It just doesn't happen. It's not allowed. So this technique is where we have to solve for x and substitute it in as well. Now we have everything in terms of u down here, and we can continue. If that does not make sense, watch it again. Think about it slowly, and let's do it from there. So now we have u to the 3/2 because we have u to the 1, which is 2 over 2, times u to the 1/2, so we add powers, u to the 3/2, minus 2u to the 1/2 du. Now this is nice, good integration, nice and easy. So we add 1 power and we have u to the 5 over 2, and the reciprocal is 2/5 minus 2 times, now this is going to be u to the 3/2, and the reciprocal is 4/3 plus c. So we can say 2/5 and then u is x plus 2 to the 5/2 minus 2 times 4 is 8 over 3 times x plus 2 to the 3/2 plus c. Now it's possible to factor back here. This is a great answer. I'm not exactly sure what WebAssign is going to want, but I've looked at it and I think they're okay with that type of an answer. But think for a minute. Let's factor out the x plus 2 to the 3/2 because it's the smallest power over there. So now I have 2/5 x plus 2. 5/2 minus 3/2 is 1, so that's an understood 1, minus 8/3 plus c. So we could distribute, clean it up a little bit. X plus 2 to the 3/2, and then I have 2/5 x plus 4/5 minus 8/3 plus c. I would love to work out that fraction for you, but I have no space. So let me do it up here. At the top I have 4/5 minus 8/3. Common denominator is 15. I don't do fractions in my head as often as I could. Common denominator is 15, so 3 times 5 is 15. 8 times 5 is 40. 3 times 5 is 15, and 3 times 4 is 12. So when we subtract, we get negative 28 over 15. So I have 2/5 x minus 28 over 15 plus c. One more time. I'm really okay with this one in parentheses. I like this one down here is just simplified. You can go either way on that. So let's look at another one. Number 46 is a similar technique that's used. And so the problem says the integration of x squared, square root of 2 plus x dx. So the reason we know it's this is because we know that u needs to be the inside of the square root, the composite function, 2 plus x. Then du equals dx. Now you know we need the technique we looked at last time because the u has a lower power than the remaining x, and there's no way for that to happen in a derivative. So we're going to, let's look at it. We say the integration of x squared, square root of u, du. So I'm going to need to take this u equals 2 plus x and solve for x. X equals u minus 2, and then put it into the bottom. So I have u minus 2 quantity squared, u to the 1/2 du. Now u minus 2 squared, write it twice and do FOIL. U minus 2, u minus 2, u to the 1/2 du. Alright, so this becomes u squared minus 4u plus 4 times u to the 1/2 du. Remember, there is no product rule, so you need to distribute. That makes u to the 2 plus 1/2 is 5/2. Minus 4u, 1 plus 1/2 is 3/2. Plus 4u to the 1/2 du. So now we can actually integrate because it's in a nice form. So we've got, when we add 1, we've got u to the 7/2, and that's the reciprocal out front is 2/7, minus 4 times. Now when we take the integral, or the antiderivative, we get u to the 5/2, the reciprocal is 2/5, plus 4. This will be u to the 3/2. So we have times 2/3 here, plus c. So if we simplify, we have 2/7 u to the 7/2 minus 8/5 u to the 5/2. So plus 8/3 u to the 3/2 plus c. Now you could factor your u out here if you wanted to. Let's go ahead and do that. We can factor out a u to the 3/2. And we have 2/7, and we're going to subtract the exponent. 7/2 minus 3/2 is 4/2, which is 2. Minus 8/5 u to the 5/2 minus 3/2 is 2/2, which is 1. Understood. Plus 8/3. That whole u went out, plus c. So we've got u, which is 2 plus x to the 3/2. Bracket 2/7, 2 plus x to the squared, minus 8/5, I said to the squared, sorry. 2 plus x plus 8/3 plus c. You could do FOIL and multiply it out. Most places don't want it. It might be necessary at some point, but it's not used extensively. So 2 plus x to the 3/2. If we were doing it, this is a good answer right here. Let's go back to that. This is a good answer right here. So I have 2/7 times 4 plus 4x plus x squared minus 8/5, 2 plus x plus 8/3 plus c. 2 plus x to the 3/2. These are messy answers. I have 2/7 x squared minus 16 over 35x plus 64 over 105 plus c. Interesting problem, but pay attention to the fact that because this x squared has a higher degree than the x in the u, that's what tells you that you need this technique. So look at number 48, and I want you to try that one. I'm going to help you get started. So start it, think about it for a minute. 47 is one of these as well, but let's look at 48. It says the integration of x to the third, the square root of x squared plus 1 dx. So we know that we're going to let u equal x squared plus 1. Then du is 2x dx. So let's solve for dx, and that's 1 over 2x du. So think about x to the third. Here I have an x. I have 1 over 2x right here. So I have an x, but let's write it separately. So I have a x times x squared, because I can see the future here, times the square root of u times 1 over 2x. Oops, that's not a minus. Du. Now I know that this x right here cancels with this x, but I still have an x left over. And it's an x squared, which works out well, because u equals x squared plus 1. So x squared equals u minus 1. So we're going to say the integration of u minus 1 times u to the 1/2. And I have a 1/2 power, so I can move that out front, du. So we have 1/2 integration, distribute, u to the 3/2 minus u to the 1/2 du. So we integrate, we have 1/2 times all of that. So u to the 3/2, we add when we get u to the 5/2, 2/5, minus this becomes u to the 3/2, 2/3, plus c. So that's going to become 1/2. We're going to distribute the 1/2. So we have 1/5 u to the 5/2 minus distribute 1/2 times 2/3 is 1/3 u to the 3/2 plus c. I think it's easier to factor, so let's factor out this u to the 3/2. I could factor out a 1/15 and do away with the fractions, but we won't do that. So 5/2 minus 3/2 is 2/2, which is 1, minus 1/3, and that would be canceled out, plus c. So u is x squared plus 1 to the 3/2. And then we have 1/5 times x squared plus 1 minus 1/3 plus c. X squared plus 1 to the 3/2. And we have 1/5 x squared plus 1/5 minus 1/3 is minus 2/15 plus c. You could write it again without the bracket so that you just have the parentheses, but it's not really necessary, so there's no need. Any questions? Feel free to email me. I think that's all I'm going to do here. There's some really good problems in there to practice. If you feel like there's any you need to see, feel free to let me know and we'll look at it. Thank you.